known. Myself, Jiffin Tony Thotan, and I am currently software engineer at that. So I am part of NFS team in Red Hat Storage. But today I am talking about a different topic, SELinux Support or GlusterFS. So before moving to my talk, I would like to take this opportunity to thank following people for their work towards this project: Brian Foster, Neil DeVos, and Manikandan. So today I will go through the following sections or following slides. So I will start with what is GlusterFS, then I will talk about SELinux in GlusterFS, then the challenges or issues which we faced while implementing the SELinux support, and how the clients can do the stuff, and where are we. So what is GlusterFS? Like, this slide might be, you have see this slide before, so sorry if it's boring or something like that. So basically, GlusterFS is an open source scale-out distributed file system which is POSIX compliant, and it's a software defined storage, and it works in the user space, and it aggregates different storage units into a single namespace. In Gluster terms we call it as a volume, and one of the important feature or like key highlight of GlusterFS is it does not have a dedicated metadata server, and it provides, or the overall GlusterFS design provides a stackable modular architecture, and it can run on any commodity hardware like our laptops or like, does not matter. And so these are the following components in GlusterFS. So basically the disk should support extended attribute like EST for XFS. That's the only requirement for a disk to be part of GlusterFS storage. Then it has following components. So there are servers which we say its name of storage bricks, or it's a GlusterFS daemon running on these storage bricks, and it exports a local file system. And at the client, we aggregate different storage units to a single point, which we call as a volume. And we have different stackable modules inside clients, which we call translators. And there's a management daemon in which we can manage volumes or add nodes to the cluster or add peers or increase the volume size and set different options for a volume, etc. And this is done with the help of CLI tool, client interface tool. And this is how the overall GlusterFS architecture will look like. So the storage admin can create a GlusterFS volume using bricks, the physical drives, and it will export each physical drives via bricks, and admin will create a volume, and user can mount or use that volume using different protocols like NFS or Swift or Fuse or OpenStack, something like that. And if you look into the internal architecture, like you can see two diagrams. Left side is server and right side is client. So each of them we call as translators. Each of them are pluggable modules, like in which you can include each feature and remove it if you want. So client will request and it will go to, like, these are default translators will be loaded at the client side. At the right side, the blue color, all the requests will go through these translators and it's sent to the server. And so in server also we can see different translators. All requests will go through these translators, and at last it will write into the POSIX layer. So before moving to next topics, do you have any doubts or questions regarding GlusterFS or its architecture or something like that? Okay. cool. Now I'll talk about SELinux in GlusterFS. So I will just give a brief intro about SELinux. I'm not an expert in SELinux. So this is just a brief intro which have few things so it provides a mandatory access control for Linux systems. SELinux can work on policies, it enforces rules based on policies, and each processes and files are labeled with context like this. You can see ls minus hyphen -z file give. The first one is the DAC, the directory access controls, the read write permissions, user group. Then you can see the SELinux one. So it has 4 parts. First one is user, second one is roles, third one is type, and last one is security level. So user is similar to the Linux user. You can map Linux user and SELinux users using SELinux policies. And then there is object. So object roles, it's kind of domain for the users, what all the user can access or something like that. And next one represents type of that file or process. So each domain can access different types of files or processes based on the SELinux policies. And last one is the security level. And which I matter is what is SELinux for the backend. So SELinux is just an extended attribute named with security.SELinux, and it stores following thing with this attribute. So, okay. And GlusterFS and SELinux. So GlusterFS is an application which works well with SELinux terms. It has all the running GlusterFS process will have following SELinux context, and user system. It means that it's run by systemd. That's why it gets system U and system R as user and role. And glusterd-t is the type for all the processes. It may be root process or client process or the management daemon which I talked about. So by default, everyone will get it get following context. And below I have listed the files which the GlusterFS process can access. So you can see the roles for a type for each file. So each which represents clusterd, in which so the GlusterFS process or Gluster processes can access those files. And one thing to be noted that bricks will be a path in a Linux system. It have following context with clusterd brick. So not all applications which uses GlusterFS support SELinux. So following are 2 applications which have SELinux context at client side as well. So one is Fuse client, which have Fuse_T type, and other is NFS client, which have NFS_T type. But today I'm not talking about this stuff. This is what we have in GlusterFS with SELinux. I am talking more about the client side representation or how we can do it. Applications can set context on clients. So currently with current GlusterFS architecture, clients cannot set different context on files which resides on a GlusterFS volume, and being SELinux provides mandatory access control. So, and GlusterFS is a file system basically, like Linux compliant or POSIX compliant file system. We need to support SELinux. So why it is not working for us? Basically, as I mentioned before, each files which access cluster process have context. So bricks have its own context. If application tries to write a context, it will overwrite the existing brick context. So it won't work with SELinux, or it won't work with GlusterFS process, won't work with SELinux and enabled environments. So we need to do some kind of hacks. So as I mentioned before, at the back end, this SELinux will be stored as a security.SELinux attribute. So we just need to map that security dot SELinux attribute to some other stuff. So this is done with help of an SELinux translator. So it does the following. So basically it stores the SELinux context from client as trusted.GlusterFS.SELinux, and it will do the mapping from client to server. Like if client set some context, it will set as trusted.GlusterFS.SELinux at the back end, and if client requests for the context, it read it from this context and give back to the client. And we need to interact following calls like setattr or getattr, mkdir, and mknode. Like these calls are system calls. In Gluster terms or in network terms, we call it as FOPs. So we need to handle following FOPs. And this translator will be loaded at the server graph by default. And so by default, every entry in the volume will get following context, which is similar to brick, and application can change the context accordingly. And one of the things which we need to note, like the internal operations related to Gluster, like self-heal or rebalance, so that should not be denied by SELinux. Like we may need to migrate one file from one brick to another, or we need to heal a file. So those operations are important for Gluster. We need not deny those operations. So we need to bypass those operations. And at the server side, we don't do anything for the enforcement. It should be handled by the client side. Like depending on the clients on the Linux system, they will handle it accordingly. And this is a small picture which I try to draw. Like this will happen at the server side. So client can send requests like chcode or restore con manage to the server, so it will be and getattr or setattr call at the server, and protocol server is the first translator which receives the call. It will go till SELinux, and SELinux will convert the call into or the value, change the value into trusted.GlusterFS.SELinux and give to POSIX, and POSIX will set that extended attribute on that file. And so after doing this, like the following are the two clients which have current support for SELinux. One is Fuse and the other one is NFS. So there is a bug in Fuse client which is not fixed yet, so the users cannot set SELinux context until fixing this issue, and they have proposed patch as well. And in case of NFS clients, like we have labeled NFS, it's a feature part of NFS 4.2, and using that, NFS clients can set the SELinux context directly without any issue, but there should be some kind of operation should be implemented at the NFS servers which Gluster is using, that is NFS Ganesha, which is also missing. So there are lots of stuff need to do in this project. And where are we now? So it was planned for 3.10, but it didn't make it up. So we have two patches processed upstream. Like one is the implementation of the translator, other one is like setting the brick context while you create or add bricks. And two more patches yet to be started or need to be done. And one of them is, so the inherited context from the parent directory should be also modified with the trusted dot appending stuff. So that is missing, and maybe for the other applications you need to provide GF APIs for managing the SELinux context. And the following are the, if you have queries or questions, you can ask, mail us or ask at IRC, and these are some useful links And yeah, do you have any questions? Or